So if you're continuing your notes from yesterday, where we started by simplifying radicals, then we went into set 2, simplifying the ones with the variables, and then set 3, where we had radical or whole numbers and variables, and now set 4, where we're simplifying radical expressions. So as we're taking a look at this, remember that we want to make sure that you're referencing your list of perfect squares. Okay, so somewhere on the side of your paper or up in the top, hopefully you have listed, 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, and so on. Okay, you list your perfect squares out so that you can reference those as you're going through this. All right, so simplify this radical expression, 6 times root 20. Can I simplify this 6? No, it's not even in the radical, right? We're done with that. We'll just circle it and move on. Root 20, is there a perfect square that goes into 20? Yeah, we start looking at these. The first one that we get to other than 1 is 4. So we have root 4. Thank you. We have root 4 by root 5. Okay? Root 4 times root 5 is 20. Remember, we use root 4 and root 5. Why don't we use root 10 and root 2? Tell your neighbor why you wouldn't use 10 and 2. Okay, Jacob, what do you think? You need to have at least one perfect square. Okay, so the 4 is our perfect square. This gives me 2. I'm done with that. And this gives me root 5, which I can't simplify. So my circles are what I have left. 6 times 2 times root 5 is 12 root 5. That is my solution, 12 root 5. I should write it over here where you can actually read it. 12 root 5. We have now simplified it. Okay? All right. Any questions on that? Yes?
Why don't you add the 2? Why don't you add 6 and 2?
I multiply them. Because I'm multiplying 6 by root 20. Therefore, it's 6 times 2. Yep.
And my second question is today going to be another competition?
Yeah, competition today, yeah. So just so you know, yesterday when we left, there were a couple people who stayed back and stacked all the chairs for those people that slacked off. So like this group back here gave this group points because Nathan stacked your chair. That was nice of him. And Logan helped out with this group back here. So you guys were amazing, benefiting, giving them some points to start out the day with. Nice. And Jacob just answered a question that I called on him on. So yes, we will be doing the competition. Very true. Okay, I want everyone to try number 27 and 28 right now, please. 27 and 28. Get as far as you can. Work with. Okay, number 27. What do we do? Thoughts? Kara?
You find what goes into the radical 60x squared.
Okay, find out what goes into the radical 60x squared. And let's go ahead and separate those two things first. Okay? And so we don't do anything with the 12. What goes into root 60?
15 and 4.
Well, I was asking Kara. She got called on.
Oh, 15 and 4?
Yeah, 15 and 4. Root 4 by root 15. Okay? Very good. How about x squared? Just x. Okay? That part we're done with now. The radical disappears. All right, so from there, this becomes root 2, or root 4, which is 2. Can I simplify root 15? Is there a perfect square that goes into it? No, so we're done. So our circles, 2 times 12 times times x times root 15. So we always put the root at the end, the house, if you think of it that way. That gives me 24x root 15. How many got it? Well done. Any questions?
I got this. Danny wants to know why we don't reduce 12 on the outside.
I'm not going to play that game where Danny wants to know. Danny has to ask her own questions.
Oh, well,
However,
I'm wondering
yeah.
if, why we don't reduce 12 on the outside because root 4 goes.
Because there's no radical symbol on it. Yeah, very true.
Thank you.
Yeah. All right, so root 2 times root 8. What is root 2 and root 8? What is it? Yeah. Root 16. You can multiply them. That's root 16. And what's the root of 16? That is 4. That's the easiest way to go. Now, you can approach that different ways, right? We could have simplified root 8 first and said root 4, root 2, which would have given us a 2, and then root 2, and root 2. Root 2 and root 2 gives us root 4. So you'd have 2 times root 4, which would be the same thing as 2 times 2, which is the same thing as 4, which is what we got right there, just quicker if we do it this way. So sometimes multiplying them together first help out. Sometimes it doesn't. Sometimes it takes less time that way, or more time that way. I want everyone to try numbers 29 and 30, please. 29 and 30. Probably not. No. 29 and 30.
Are you supposed to get a decimal?
Okay, volunteer on number 29.
Oh boy.
Yeah, Abby.
Okay. Well, first I multiplied the 2 and I got square root of 180, then I divided. Then you split it into square root of 36 and square root of 5, and then the end is the square root of 36 is 6, 6 square root of 5.
Well done. How many got 6 root 5 there? It's very true, yeah. Now there's a couple ways you could get there. That's the most direct route, yeah. Did anyone go 9 and 20? And then break it apart from there? Okay, that works out.
36 and oh wow,
Yeah.
that's perfect.
Yep. Okay. How about number 30? Yeah.
No, 12 times 27 is 324. Then square root that, and it's 18.
Good, yeah. Root 324, and if you know your perfect squares, that breaks right to 18. Well done, man. Yeah.
Are you a D 36 and 5?
Huh?
Are you a D 36 and 5? 36 is we're gonna like split it.
Right here?
Yeah, we're gonna split it.
36 is. Yeah, 6 times 6. He's just joking. All right. All right, any other questions? Okay, let's move on. Number 31. Hey, remember with fractions, all you have to do is break apart the fraction. You got root 7 and root 9. Break it apart like that. Now remember, the rules are you can't have a fraction under the radical. And so we do this, and now the rule is you can't have a
Square root.
square root where? Declan?
It would be 3 on the bottom and square root 7.
Good, yeah. Nice job. Okay. Can't have a radical in the denominator. In this case, the denominator is a perfect square. That makes it easy. Is root 7 perfect?
No.
Is there anything that goes into it that's perfect? No. Other than 1? No. Okay, everyone try number 32. And then 33, please. 32 and 33. Compare them with your neighbors.
Oh wait,
5 times 5 is I think you have to split them up.
Okay, wrap it up. Number 32, person number 9. 9. Who's 9?
Graham. How'd you know? Sorry. Do you want me to say the answer? Or?
Yeah, what'd you do?
I did 17 over 64.
So root 17 over root 64. Okay.
And I got root 17 over 8.
Root 17 over 8. Good. Perfect square on the bottom. Well done. All right, that is correctamundo. Any questions there? Good job. All right, person 6, number 33. This one's a little tougher. Person 6. Who's 6?
I know who it is. Just kidding. I don't know.
Okay, 16.
I don't know that.
Is that you?
Anderson 6.
Too late.
16. Is that you? Okay, I thought it was
Anderson 6.
23.
Oh, that's me.
Is it?
No, it's not.
Number
No,
4.
it's Trevor.
4.
Oh, no, I'm 23. Isn't Ashley 4? Yeah, Ashley.
Are you 23?
Yeah, he is.
Oh, okay. Go ahead, Declan.
I'm actually 23. Okay, oh god. Okay, so this is probably wrong, but, so 33, I reduced it to, so I put, first, I put the square root of 120 over the square root of 10. And then I broke the square root of 120, because you can't break the square root of 10. There's nothing there. And I got, square root of 4 and the square root of 30. And then I reduced the square root of 4. And got 2. So 2 square root 30 over square root 10.
2 root 30 over root 10.
Is that right?
You can't do that because you can't
Yeah.
square it.
You could start doing that. You still have a square root on the bottom, so we've got a problem. So a lot easier way. Abby?
Okay, well, can't you break the square root of 10 down into square root of 9? Wait. Oh, wait.
McKenna?
Okay, so you, this is just again standing mind of this together, but, you, like, divide them into 12, and then you go, square root of 1, square root of 3, and then that's 2 and 3, so then it'd be 2 square root of 3.
Okay, reduce the fraction.
Oh.
Okay, if it's not already perfect, 120 divided by 10 is 12. So that becomes root 12. And then the square root of 12 becomes root 4 times root 3, which is 2 root 3. Very well done.
Wait, here, can you go?
Can I have credit for that's what
Okay.
I did? Wait, can we get a point? Yeah, we do. Wait,
So root 120 divided by root 10, that reduces to 12. Break root 12 into root 4 by root 3, which root 4 is 2, 2 root 3. Okay, so if you have to, simplify the fraction first. Now that doesn't help over here because you have a perfect square on the bottom. But here you don't have a perfect square. Okay? All right.
I have a question.
Yeah?
Okay, so, like for the next one, couldn't you break like...
Well, hold on. I want everyone to try number 34 on their own first. Okay? Give 34 a shot. Go ahead and compare your work. Discuss it.
Okay, so I got 2 square root of 12 over.
I'm not sure. I carried the whole, like,
All right. So my first question, if I can have your attention back up here, can I reduce 48 and 8?
You can't divide them.
Who says, yep, you can reduce these two? Who says, nope, you can't divide those two? You can't.
The top is a square root.
Okay. Can't divide them because the top's a root. Bottom isn't. Okay? So, what do I do? Let's go with number 12. Who's 12? Yeah. Nathan.
I don't really know what to do. I just I kept the 8 and then I did I did 16 and 4 for 48.
Okay, so root 48 breaks
No,
into
3 and 16.
root 16 and root 3. That's true. And 16 is
4.
4 root 3. So the top becomes 4 root 3. The bottom stays
8.
8. So we have 4 root 3 over 8. Okay? Abby.
Okay, so that's why I got 2, but then I was wondering if you could divide both sides by 4, so then you just have square root of 3 over 2.
Everyone hear that question? Can we reduce the 4/8? The answer is yeah, because they're both outside of the root, or outside of the house, if you want to think of it that way. Okay? That becomes 1, and that becomes 2. So it becomes root 3 over 2. Really? I wasn't joking. Yeah. We got a root 3 over 2. Sam.
For the roots on the top, I did 4 and 12.
Yep, and so you would break the 4, but then you'd have root 12, which 4 goes into also, so you'd have to keep reducing. So if you make the top root 4 by root 12, this part's going to become 2, but then you've got to break this into root 4, root 3.
Yeah, and then you get 2.
You get 2 again, so that's 4 root 3. Okay?
That's what I did wrong. So I just multiplied it. How
Bless
do you
you.
get 35?
So what's wrong with 35?
They're both off. Or the first
Everything.
off.
Rylan, what's wrong with 35?
You can't reduce it.
No. Josh?
Top one's odd, and the bottom one is a radical.
Bottom one's a radical. It doesn't matter what the top is. Bottom's a radical. How do we get rid of the radical in the denominator? Declan?
Normally you reduce the fraction. You multiply.
Can't reduce them.
Oh, you multiply. You multiply by 1.
By 1. In what form?
Well, the same thing as the fraction right there. So it would be 5 over square root of 2.
No?
Oh, I know.
Oh,
Yeah?
No. Square root 2 over square root 2.
over square root 2.
Good. You multiply by root 2 over root 2. Okay? Root 2 over root 2. That's the number 1, right? Where did we get the root 2? From the bottom. So this becomes 5 root 2. And what do we end up with on the bottom? Root 4, which is 2. Can I reduce the 2's?
Wait, how do you get 5 root 2 over 2 though? Because
Okay, hold on one second. Can I reduce the 2's?
no.
No, one's inside, one's outside. Can I reduce 5 halves?
No.
No, there's nothing to reduce there. How do I get the 2? Root 2 times root 2 is root 4.
Yeah, I get it now.
And root 4 is 2. Or just take the thing inside. Okay. Want everyone try number 39. Here we go, number 39. Okay, right now it's a very close ball game. All right, I'm going to call a number here. Here we go. Person number 8. Yes.
Oh my god.
What do I do?
Okay, well first you multiply it by the square root of 3 over 3.
Oh,
Square root of 3. No, square root of 3.
Okay.
Yeah.
Now what?
Then you take the denominator is 3, and the numerator is square root of 3, right?
Yes.
3 times square root of 3.
All right.
Yes.
Take it easy. All right, now what? Anderson.
Then you divide the top 3 by the bottom 3.
And so my answer is?
Square root 3.
Root 3. Very good. All right. Hey, right now it's a 3-way tie, just so you know. 1, 2, and 3 groups have a tie. Okay, we'll figure out how we're going to break that tie here in a minute. But right now,